Assalamu alaikum, ladies and gentlemen. Welcome to my presentation. I'm Diyar Saadi Ali, Kurdish, old school cyber guy since 2011. So today we are focused on a specific mobile threat. It's a ransom locker. So it's actually ransom. Locker is not a ransomware, but because it have some kind of a component of a ransom, we call it ransom lockers. There are we have a dozen of technical talks about some kind of ransomware or miners or wipers or worms or until end. But actually, when we come into a mobile threat, we only have some kind of a common threat that available on for other operation system like Trojan or Stealers and Creepers, SMS loggers, and so on. But when it came into ransomware, actually there are less talkers about it, and there are less technical reports of mobile ransom lockers. Inshallah, today we dive into this topic and how to analyze it, how to prevention, how attacker operate, the kill chain of the mobile malware, and so on. Who am I? I am Diyar Saadi Ali, as I mentioned it. I have nearly 11 to 12 years of experience in this field, with an offensive mindset to build a great defense. So I'm one of the metric contributor. I have a two technique. It's an enterprise technique also. It's not a small ones. And also I have a two CVEs for specific CMS. And also I have a talks in CyberSec 2025, DeepSec in Vienna, Arab Cybersecurity Conference in Cairo, Suli CyberCon in Suleimania, Iraq, and also I have attended JISEC as a participator to see what's new in a cyber landscape. In addition, I'm an author, so I have nearly two books related to cyber forensic and cyber threat on a social media, and I have nearly 10 to 12 TV appearances in my country. So our table of content today, it's a appear to be small, but actually it's a inner core of understanding a mobile thread and Android internal and some iOS layer. I mean iPhone devices. So first of all, we will talk about the mobile architecture and component, then mobile ransomware component, then mobile malware infection chain. So how the infection is work, and then in demo analyzes. Um, Actually, mobile architecture. So as a human, we have an architecture. We have a head, we have a hands, we have a brain, we have a eyes, we have a nose, and we have a legs, and so on. So actually, mobile devices have an architecture by itself. So it's a SIM, display, and battery like a soul. A microphone is a ear, and display is your faces, and also the speaker is your ear, and the camera is your eyes. Okay, and your Bluetooth is the transmission between person to person. Okay, um, it's actually we have a RAM, we have a room, and we have an application, CPU, memories, and so on. And we have an antenna also for our RF switch and so on. And also we have a SIM card. It's like a small brain to say to save a name is and person and people. So there are no big difference, I think, between this architecture and human at all in this perspective. So actually mobile architecture, what the mobile architecture is actually in a software layer, is not in a hardware layer, because they are different. So mobile architecture is a stand for the design and the structure of this mobile application, including how they operate and perform, and how they start their functionality. So devices also like a smartphone or the tablet. Okay, that's a mobile phone. Actually, we have a dozen of stuff like applications, application framework, and the libraries and runtime and the kernel. So if you may not know that Android devices is based on a Linux kernel. So in a final stage, they have drivers. Okay, so the Linux kernel is a make a communicate with the application. Okay, and a application framework and also a library. So in a Windows we have a DLL file. It's called HIL.dll. So HAL.dll. It's a bridge between the hardware devices, hardware driver, and with the computer itself. Or we can say it's like a NTDLL. So that's a bridge between a user mode and a kernel mode. So in application, so we have the normal application itself, like a media player, calendars, email, voice deals, contact, and so on. And if we come into the application framework, we have activity managers, so the package manager, telephony manager, resources, and a view system, and so on. So actually, the activity manager and the package manager and also content provider, they are necessary for each Android application that itself. And also we have a library. So in a programming language we have a libraries. In Windows itself we have a libraries. So what's the library is it? So it's a SSL and SQLite. So actually, Android application is relying on a SQLite and Surface Manager Media Framework. And also in a driver itself we have a normal driver like each computer is have. So of course our computer have a Bluetooth device, Bluetooth drivers and flash memory drivers. So without these drivers the hardware is doesn't work, so it cannot make a communication. So there are no communication if this driver is not installed with the user space, okay, or with the user mode, because this driver will be recognized into this software, and this software will start communication through COM or IPC. And actually in iOS, so our talk is a more far away about the iOS, but actually we have to know the core or the architecture of each iOS application. Okay, so we have a Coca Touch, so it's an application like we have here. So and we have a media layers, and we have a core service, and we have a core OS layer. So core OS layers you can imagine as a kernel, and core service we have a SQLite and core location core data and a WebKit. Okay, it's the same in Android in a architecture in hierarchy. Um, so each Android application, each Android application have activities, have services, so have a content providers. Also, it have a broadcast receivers. So in activities we have some stuff like a single screen of UI. So UI is like this normal graphical user interface on your Facebook app or on your Signal app or on your WhatsApp or in your Gmail application could be. So each activities is isolated from each other, so there are no mixture between each activities. So it could be some kind of a glitches, or maybe it's some bugs on this update version, but actually in itself in a normal update is without no bugs. Each activities is separated or isolated from each others. Okay, but remember this isolation is a very different that network isolation, or we can say, or IAGP network. um, we have a services. So actually in a Windows we have a services, and those services is run in background. So we have some application that run in background, and some of them run on foreground. But actually services or processes, they are run in background, so there are no user interface, so there are no graphical user interface. So actually it's a nature of the services that perform a long running operation. So they are running for a long time, because if the services are stopped, these devices cannot operate based on the services. So you can imagine if we stop services like a Windows update, if we stop it, so we cannot update our Windows devices, because actually when you click the button update on your setting, they call the services, and their services doing this operation. So when we stop the services, actually the update is no happen. So we have a content provider also. The content provider is a shared of application data, like a file system, or this data will be structured on a SQLite. And we have a broadcast receiver. So broadcast receiver is like the notification that you get from your device itself, like if the battery is low. And also this broadcast receiver know have a user interface. So make this word that processes or services, they have no user interface. Of course, broadcast receiver itself. And so maybe um as, from the security researcher, we will hear some stuffs like, so why Android is vulnerable. So it is depend on open source, or they depend of what. So actually, Android itself, it could be vulnerable, like each devices, like each hardware devices, each mobile devices, everything is vulnerable. If it is smart, it is vulnerable because it's written by human, and human is making mistakes. Okay. So but the main reason that Android devices or Android operation system is targeted by threat actor is not by this device itself. It is based on these users. So Android have a millions and millions and million users. So I believe the Android users, they are more than iOS devices or iOS operating system. Why? Because it's a open source, it's a low cost, and so on. But actually, Android operation by itself, it's a multi-crisis platform. So they are in healthcare, in a finance, in a e-commerce, games, transportation. So in Iraq, our bosses have the tablet, and this tablet is run Android operation system. So why? Because it's a cheap and works smoothly and very well. So the targeted of Android operating system is not based on that it's vulnerable. It's actually based on they have a multi-million users. So you can imagine if someone is a fisher, so they have an interest to hunting the fish. The fisher, or we can say the hunter, will not visit the sea or the lake that have a small fishes, or maybe the small amount of fishes. So they will visit some places that contain thousand or million fishes to get dozen of fishes. So actually, iOS, they are limited across this platform. They are maybe only run on Apple-based devices like TV OS, Watch OS, or Mac OS, and so on. Not like Android that available in everywhere, like hospitals, e-commerce, social media, transportation, and so on. And also, um so, uh, why Android as a cross platform? So why someone that set up a transportation, maybe in a m-commerce, why choose Android as a cross platform, or the main operating system? So because media supporters, optimized graphics, and GSM technology, of course, and in inner core, it's a powerful operating system, and as user friendly. If you have a Android or in a day of your life, and you know how it's easy to install any kind of the application. So also reduce the development cost. So in a business, the businessman or the businesswoman or the HR, the human resource guy, trying to solve this issue in a less cost. That's why Android selected as a cross platform, and people, businessman, or maybe transportation, or the station relying on it. And malware component. So everything have a component. Your cars, your bicycle, your mobile devices, your computer based, your speakers, and so on. Okay, even your bodies have a component. So a malware component is stand for a specific module of a malicious software. So malicious software means the malware. So that performing a specific or particular function to help the malware achieve this goal. For example, it could be a stealer malware have one modules. This module is searching for or enumerating the IV processes or the EDR processes or any kind of sandbox processes. So this module is called component, and this component help the malware itself, to achieve their goal. Okay, so actually malware is came from different stages that we discuss in the next slide, inshallah. So malware component chain. So actually, each malware, we can say nowadays, not like a past. So if you are old school, some guys who are deploying dark comment, artmax keyloggers, ngrot, or spynode, or spymax, and xamarin rat, and so on. So it actually, this rat by itself generate a server or a trojan server. So after time to time, the antivirus start evolution and detecting this payload. So the malware author stopping relying on this first chain. So it start to changing their behaviors and changing the way to achieving their harmful goals. So we have a payload. So payload is a harmful action that the malware perform, or we can say it's a bogus that contain a malicious function, and so on. So droppers. So what's actually dropper is? So it's very easy to understand. Actually, dropper. What is it? So the name calling itself. So imagine you have a box. Okay, you have a box, and inside this box you have another box. So actually, this small box is an original malware that dropped by the big one box. That's a dropper. So let us back to a Windows pilot. So each Windows application have some sections like a .text, .data, .idata, .resource, .idata, and so on. So actually, the malware author trying to embed another executable file in a resource section. So it called the dropper. So when you double click on the malicious executable file, the first stage is extracting the second stage of the malware that embedded on resource section. That's a dropper yourself. So we have other terms. So someone call CC, someone call C2, someone call CNC, or you can say command control server. You are free what you want to call it. So the CNC command control server, it's make a communication channel. It make a communication channel between between the attacker, or we can say the bot master, and the victim itself. That's a CC simply. I'll try to simplify the stuff to you to understand the inner core. And actually, we have exploited. So actually, exploit is it's a well known. It's a weakness or security flaw in a system or specific predicate that malware uses to performing their malicious behavior. And we have some types of exploits. So we will discuss inshallah in the next slides. So we have some types of the malware. So we have a Trojan, we have a spyware, we have a adware, we have a bunker, we have a ransomware, and we have a keylogger. So actually, we have a dozen of a type of one, like a wiper or wipeware. It's actually wiping your operation system on your devices. So actually, spyware, it's a call itself. It's a for espionage, and adware is a putting the advertising notification on your device, and keylogger actually hooking the keyboard or the keystroke that you've written and sent to command control server. And ransomware actually it's a type of a malware that encrypting your device, and you have to pay the ransom to get the decryption software or the decryption tool. And the bunker, so the bunker we have a Zeus and Druidicus and Trickbot and Emotet and some kind like that. So bunker actually it's a type of malware that's stealing a banking stub or credit card or something like that. So we have some a well-known mobile malware like a Kabir. Kabir, it's one of the first mobile worm that spread via Bluetooth. Okay, it's a spread via Bluetooth. And Com Warrior, so it's a spread through MMS. So we have a SMS, we have a MMS. I don't remember the long term of SMS and MMS, but actually in a MMS you can send long characters more than SMS and send the media content is. So it also infecting through Bluetooth and specifically designed for infecting Symbian based devices. And we have Zitmo. So Zitmo and Zeus, they are close to each other. So it's a mobile version of the Zeus banking Trojan that intercepting SMS code and OTPs and something like that. Um, so mobile malware infection chain. Oh, it's one of the most important. So we have a cyber kill chain. So what's cyber kill chain process is? So it's a reconnaissance, it's an exploitation, it's a weaponization, delivery, and command and control, and objective and goals and until end. So actually, I will simplify it or shorten this kill chain into a malware mobile based devices. So first of all, we need to delivery how the attacker deliver this malware to you. So the answer is very easy. It could be from the official Google Play Store, or it could be on IPCure, or it called side loading uh, attack. Or so it's attacker will upload on on this IPK file on IPCure or into up to date. There are another application that can be used for downloading Android application, or the victim starting to download it and infected this device. Or it could be by third party app stores, okay, as we mentioned it. Or it could be by exploiting the third party services, so like a supply chain attack. And also execution. So how execution is happening when user actually install the malware or install this application. So the after a few minutes, it could be on the delay, or the delay that a malware author put on the code. So we have a direct hotel operation. The malware not starting until waiting for 180 days. So it depends on the malware. Okay, but actually maybe the maximum for a normal malware it could be 1 minute to 5 minutes. Sometimes less. Sometimes directly when the victim download the application start infecting. So the exploitation, what is it? So actually exploitation, this malware start to taking maybe vulnerability, exploiting the vulnerabilities to start rooting the devices. So we have a dozen of a kind of the malware that start to jailbreaking or rooting the device after the installation to take a control of the device completely. So you can imagine this type of the malware that I mentioned it as a as a rootkit or bootkit that try to work on the ring zero. So in a Windows, actually we have a ring zero. So it's called ring protection. Okay, CPU ring protection. And actually the zero ring, it's a you have a full privilege. You are in a kernel mode, so you can manipulate the kernel object and so on. So actually we have a pilot activation. So pilot activation, again, pilot activation, it's a depend on the malware and the operation and the campaign itself. So as I mentioned, there are some malwares that start automatically after installation, and there are other malwares that because the operation is a long term, trying to delay the activation. And also there are maybe use the sleep evasion. So if you have experience in a malware um, malware development, actually I'm not developing the malware, but I will investigating a malware itself. So they are using the sleep the sleep evasion. Okay, um, so the sleep evasion is a technique that using for evade detection. And actually there are a small arts of what I said in a previous slide is the admin is download a game, and the game install all malware act as droppers or downloaders. So actually, what is downloader is? Um, for example, it's a main application. Okay, it's a main application, and the attacker is storing another application in cloud, and this main application is downloaded and executed automatically. Okay, that's a downloader. So actually, downloader is a type of the malware, or the malware action that download another payload, or that hosted, could be in a GitHub, on Google Drive, on a Mega or Dropbox, on compromised website. So let's delete this art. Okay, shade and okay, good. And actually, we have sometimes like a bot master. So actually, what is a bot master is, and what's the botnet is. So actually, botnet simply, in a simple term, in a one-on-one, the botnet is a collection of thousand of hundred of infected device that connected by attackers. So in this term, attacker is a bot master, and this bot master sending instruction to these devices, maybe for performing DDoS attack, for crypto mining, or for maybe some kind of the operation. But actually, botnet, or using for booter operation for DDoS attack, or TDoS attack, or DOS attack. In some other attacks could be for crypto mining and malware infection chain. So they are nice codes. So in order to know your enemy, you have to be your enemy. So without have attribution and have the brief information about your adversary, actually you cannot start a fight with them. So we have to know what adversary that attacker have, or our enemies have, or threat actors, or hackers, what's their adversary. So their adversary, they are public tools, so remote access tool. So we have a dozen remote access Trojan tools. So Android, Darkome, Nanoco, Capsurat, and there are dozen type of Windows rats, or we have a Spynote, Spymax, and Lahmon, and we have a dozen type of malware like Anubis and Hookboat, some kind like that. So the other type of the adversary weapon is a leaked malware source code. So please remember, in each operation, or each campaign, or each targeted attack, or in each cyber attack, it doesn't mean that attacker writing or written this malware in a beginning. No, it's wrong. Sometimes attacker relying on leaked source code, on a leaked source code, and adding some another functionality, or rewriting and copy pasting something else, and prepare it and implement the attack through spear phishing mail, through watering hole attack, through phishing, spear phishing, and smishing, until end. And we have another kind of the exploit is, so we have a public exploit, we have an end day exploit, we have a 1 day exploit, and we have a 0 day exploit, and we have a 1 click exploit, and we have a 0 click exploit. So I will not dive into the inner core of how those exploits is work, because it's a take more than hours how this exploit is work, how infection chain is start, and something like that, because it take a long time. But actually, end-day exploit is a type of the vulnerability is doesn't patch it by users. In this case, there are vulnerabilities that patch it by vendor publishes the patch, but actually user doesn't apply, But one day exploit, one day exploit, it's a vulnerability that publish it, but vendors doesn't release a patch for it, doesn't release a patch for it. So we can say there are dozen cases of IoT devices that there are dozen of vulnerabilities, but there are no patches. So actually, 0 days exploit, it's a known security flaws on specific vendors or application, but still the vendor doesn't aware about it. And actually, what's the lockers? So simply, what's the locker itself? So the locker is a malware that lock your device or lock your phone screen or files and ask the money to unlock it. But remember, the locker is not a ransomware. Locker is not a ransomware. And why? Because the locker have the some functionality or component that ransomware has. So we will describe in the next slides. But actually, locker is a type of a malware that lock your phone screen or ask for the specific code. So sometimes attacker put their Telegram bot or their Proton email or Gmail email address to pay the unlocked code and done. So actually, Secret Locker is a ransom. The answer is no. So why? So um, there are some misconception of a virus classification. Okay, if you try to upload process hacker onto virus total, automatically it mentions the hack tool, while the process explorer is one of the specific tool that used by malware analysts to monitor the suspicious processes, like a process explorer or like a system explorer or like a task manager. So actually, Locker have the some functionality that the ransomware have, like locking the device, require the code to unlock, make the device inaccessible or unusable, require payment. But remember, the locker doesn't encrypt your files at all. In most cases, I have seen the locker is not encrypting your file. It just require the key to unlock, and you have to pay, or you can say pay the ransom in the common term. Actually, it's not the ransom. So the pay the unlocked code to get your device accessible. So that's a great evidence that the locker is not ransomware. So there are three type of the malware. They don't have a component of other malware. It's a wiper. So wiper is actually not stealing your data. It's not a stealer. It's just wiping your operating system, delete the physical disks, or write your boot sector. Okay, and the worm, it's not stealing your data at all. The worm, we have some worms that's stealing your data, but actually the main goal of worm is a propagate through SMB, through RDP, through network share, and through other protocols. And we have a Trojan. So Trojan is a of course we have a Trojan that have a subcomponent of other malware, but actually in a core, the Trojan itself, it's a different kind of the malware. And Locker is. So we have a mal permission. So mal permission is done for malicious permission. So there are some permission that a locker have. One of them is one of them is writing external storage. Is writing, where is it? Yeah, it's a writing your where is it? Let's fix it. So this one, the writing external storage, in most cases that use it for dropping or for writing extend a file. Okay, and set wallpaper. Actually, it's in a Windows ransomware itself. So it's for changing wallpaper of your mobile devices. And actually, it access Wi-Fi state, access file location, and Android permission receivable complaint. It's a mostly used for persistence, so persistent mechanism. So in Windows we have a shell startup, public user, run once, task schedule, WMIK, WMIK, or services, and bootlogon and so on. So actually in Android, so boot receive completed, it's one of the permissions that use it for a persistent. So actually it's a record your audio and access media location, right settings, and kill background processes, and so on. So there are another malicious permission like set lock task package, device policy manager, get device ID, get subscriber ID, SMS manager, activity network information, get external storage directory to write the external stuff into it, and so on. So it's like a malicious permission that we have in a Windows. And there are a common tools of trade that use it for Android analyzers. So IPK tool, it's a static analysis. It's used for decompiling. And JavaScript GUI, or we can say dev decompiler, or any kind of the Java decompiler. But JADIC is a well known. So it's a for static analysis also. And we have a mob SF. Actually, it's an online based, and of course you can install the setup file on your device. It would work by Flask on your local host, and it's used for or static analysis or dynamic analysis. And you have a dex2 jar. So after the decompiling by IPK tool, and reading the manifest and another information resources and assets or string is, so you can use the dex2 jar to convert this IPK file into jar file, and use GDGUI JADX to read the source code. And we have a Frida. So Frida is for dynamic analysis, Android books for dynamic analysis, and also Genymotion. So Genymotion, I mostly use the Genymotion for emulation and dynamic analysis. Also, actually, I am not relying on tools at all. I'm just trying to use this asset that available on my device. Sometimes I am not just trying to upload a malware into Virus Total, onto Hybrid Analysis, onto Triage, and you run file scan and until M. So just trying to using the manual batch script in PowerShell or Python to starting analyzing. So I will try to get the file hash in a PowerShell of this locker. So it's important for collecting IOC's indicator of compromise. And I got the MD5 or SHA-256. Actually, I did the little OSINT, okay, to classification this sample that we have. So actually, the file name that use it is Hack Castle Clash or Bat6 or Hack Castle Clash again. And also the threat category is a Clipper. So Clipper is a keylogger, just stealing your keystroke. And Trojan unlock the screen, so it's a locker. And the malware genre is a locker, and the ransomware. Why? Because it have some classification of the ransomware, and it's from S-locker family. And then, so it's a graph overview. So we have the main APK file, and it's a S-locker and S-locker ransomware, and the connected IP is not very important to us, and they are dropping some other files. So I did some CTI or OSINT to find the similar samples. So there are Wi-Fi hack, and there are other application that have the same similarity. So The similarity is by code block, by code block, or by the code structure. And this our sample is actually have some permissions, like Android permission receive boot completed to set up a persistence, and the main service is com.lolollo and log services, so the name call itself, and we have the packages and the SDK version, and also the main activity we have a com.lollo and main activity itself, but the most important is a behavior. So the behavior is execute os commands, get the system services, and start the services. So remember this three behavior to other slides. So we will connecting the dot each other inshallah. So actually we have a manifest in a Android application. In Android application, of course, it have the manifest. So actually, so what's the manifest is? So actually, manifest is a metadata about of this application. So each photo, each video, or each files that have a metadata. Of course, it can be tampered or wipe it like an event logs, but actually it's an important information that available. So in a manifest, you can see the package name, the permission, the SDK version, and other information that related on our sample. But actually, our interested permission that we have is a set wallpaper and receive with completed and system alert window. Let's see why. So actually, it's important to analyze a string to get a more information. So there are some tools you can rely on, such as IPK Editor Studio, available on Windows. You can go to the value on assets, visit the values, and then string.xml to get a more information about the strings. So actually, boot receiver. So actually, in here we have the intent, and this intent is have a main activity. Okay, and the main activity actually itself here, call it again by the name of a context and start activity. So actually, the second code, so the second red border is calling here to start their main initialization of this infected device. Okay, let's see why. So actually, the starting services in here is a log service. So the log services is actually responsible for whole operation of the infection. Okay, and also in here we have a something great called a toast message. So remember this test message also. Okay, when you enter the wrong decryption key, this toast message is appear. So maybe a security researcher, oh, this application is written by Russian threat actor, but actually the threat actor is trying to mimicking you as a security analyst or misdirecting you. The one of the most challenging stuff in analyzing malware on attribution of a cyber adversaries is attribution itself. It's a very easy to pretending um to other IPT group or spider group or hacktivist group. Okay, so do not fall into this trap. If this malware is written into Arabic, so this malware escaped from Middle East. No, I can get the TTPs of the Middle Eastern attackers or spiders or IPTs and trying to collecting them each other implement the attack, so other security research came, okay, the TTPs is for IPT blah 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 and IPT blah blah blah, but actually is not. So do not fall this trap. So actually, I have did some text analysis. So this Russian text machine you have used the cheaters or software to hack gamers, and there's not a fire, and you are being punished for what you did, and you have to pay to to get your device back. So when you decryption code is wrong, it call you the loser. So actually, this malware, this leaked source code is a vulnerable. Why? So remember, please, malware also is vulnerable of hard-coded key, poorly obfuscation, poorly code writing, and poorly encryption. So I have seen dozen of malware types that using base 64 or using the XOR, but the key that using for decryption, so it's embedded inside the code itself. So this sample is it's a vulnerable in a every in a different layers, in a obfuscation, encryption, hard coded keys, also in a obfuscation and code writing. So actually, hard coded decryption key. So actually, it mentioned if this text box, I mean, let's see, back. This text box, okay, or this text box is, yeah, is equals to 775, remove this view, okay, or if not, show the loser message. So actually, it's a hard-coded code, and they are vulnerable malware itself. And actually, the slocker. Okay, so we are in a classes log service. Okay, and we have the view, and the view is this background you see on your screen that I said for a decryption key. It mentioned if this view. So okay, I have bordered the view of red. If this text box is equal to 775, so remove it. So your device will be accessible again. So imagine it's a application that for hacking Wi-Fi. So I will try to enter the wrong key. Okay, it told me the losers. But actually, when I writing a correct decryption code, so it told me your device is accessible. So actually, you can trying to hunting persistent through IDB by using PM list package and using the grep. So grep is a you can be using for log analysis with cut, okay, and also PM path and through logcat, also logcat like a watchdog Python libraries. It's for using for watching process or PS tooling. And also, I have entered this command pmlist package grep com.lolollo. So I have found it here. So it's a call as a drop. And also, I'm hunting for the persistence here. If you see, I have border it with a red rectangle. And also, it's a leaked sample actually. It's an attribution. So maybe we sometimes as a security researcher we are realizing that this malware actually it's written by threat actor itself. No, it's a leaked source code. How? So actually, it's doing some OSINT to find this malware type. So actually, it's a S locker. So it's a pretended to be a Android version of WannaCry. So it's actually to rebuild. You can use APK tool to start or any kind of Android application compiler. So actually, a recap of the analysis processes. Actually, the attacker uses the liquid source code to build the malware. Decryption key is stored inside the malicious application itself. Attackers doesn't use any kind of the encryption algorithm and obfuscation. And also, malware is from SLocker family, and malware doesn't encrypting your data. So actually, just for more information, that there are sometimes of a wiper or ransomware doesn't need encryption at all in most cases. Why? Because it just when your device has been infected automatically, what's the useful or benefit of a antivirus software? So when the wiper is wiped my C drive or my physical drive, so what's the benefit of a antivirus software? So I am done. So if you have any question, so I am ready. Yeah.
Maybe the oh.
Um. Sorry, I don't hear you, Dragos.
So we're just waiting for someone to turn the speakers off, and they're manning it live. So I think
Yeah.
I can do the relaying of the questions first. So if there's
Okay.
someone there who has questions, I'll just come and bring the interview cam here to them. Any questions?
Okay. Oh.
Got to be one.
Yes, I have one.
Okay, here you go.
So my question is born more out of curiosity than anything else. Um,
Okay.
so a typical mobile device will have two processors, the application processor, under which Android runs, and something else called a baseband processor, which is
Mm.
usually meant for communication purposes with your antenna. And that's
Mm.
run on a different set of software, usually hosted by Qualcomm, and it's proprietary.
Yeah.
Um, are there concerns of supply chain attacks by sophisticated actors on the baseband? Is that something
So
that we
so
is that an emerging
actually
thing that we have to worry about?
Okay, now we got to
so
bring him back.
actually so actually in a cyberspace, or we can say in a cyber attack, so everything is a imaginable.
Thank you.
So I can answer the question.
Uh, you answered the question. Yes, please. Thank you very much. I'm gonna